Okay, so continuing on, you can actually also find the scalar equation of a line in 2D. And in order to do that, you need to know how to find a normal to the line. Because another way to form the equation is to use a vector that's perpendicular to the line rather than one that's parallel. So if we were to find the normal of the line, we need to first know what the slope is, then state the direction vector. Then we're going to state the normal such that m dot n is equal to 0. That's what we want for the normal. So let's try again for the second one. Here, we can just read out our direction vector, 2, 5. Our normal has to be a vector that when dotted with m is going to be equal to 0. So here, we can use minus 5, 2 as the normal. And we can do our double check. Those two vectors are equal to 0 when dotted together. So let's see how we can use those in an example. So what we want to do is find the equation of the line with normal 5, 2, which passes through the point minus 2, 1. And we're going to write the equation of the line in the form ax plus by plus c equals 0. So what are we given? We are given, we don't actually need this part. We're given n, which is equal to 5, 2, and I will tell you a secret. If we let the vector n be represented by a and b, we can actually substitute those directly into our standard form of the equation of a line. So let's try that. So our normal is 5, 2. So that means in our equation, a equals 5 and b equals 2. So then we have 5x plus 2y plus c equals 0. Now we have to figure out what c is. So we can sub in our point and solve for c. So 5 times minus 2 plus 2 times 1 plus c equals 0. When you rearrange all of that, you will find that c equals 8, which means that the equation of the line that we're looking for is 5x plus 2y plus 8 equals 0. So these two components here represent our normal vector. If you want to double check, you can find it by finding the direction vector, going the long way, and then rearranging into standard form to double check that it works. So how else can we use this? Well, we want to know how to find the scalar equation of the straight line. So let's do another example here. We'll do one more, and then we're going to find the distance from a point to a line. So here, we're looking for the scalar equations of the straight line with normal minus 6, 4 that passes through the point minus 3, minus 7. So here we're applying the fact that I showed you in the last one, that our normal is equal to AB. So if we have our normal as minus 6, 4, that means that our standard form of the equation of a line is going to be minus 6x plus 4y plus c equals 0. Now we are going to sub in minus 3 minus 7. And so we've got minus 6 times minus 3 plus 4 minus 7 plus c equals 0. Here we get 18 minus 28 plus c equals 0, which is going to rearrange to give us c equals positive 10. So now we have our standard form of the equation of the line as minus 6x plus 4y plus 10 equals 0. Now hold on we need this coefficient to be positive. So what we can do is we are going to divide each term by minus 2. So minus 6 divided by minus 2 is 3x minus 2y minus 5 equals 0, which is our final answer for the equation of a line. What you also might have noticed, if you were clever at the beginning, that if you go back up to your normal vector, we know that we can rewrite vectors as scalar multiples. So we can actually take out minus 2 right away, which doesn't change anything, except it makes your numbers a little bit smaller, makes your solution a little bit more efficient, because you don't have to divide at the end because you did it right at the start. The last thing that we're going to look at is finding the distance from a point to a line. So we can use this formula, the distance from a point to a line, x1, y1, to the line ax plus by plus c is given by the formula a plus, we'll do capital B there, a squared plus b squared. And so what we want to do is just an example of plugging the numbers into the formula. Find the distance from the point Q, 5, 8, to the line 7x plus y minus 23 equals 0. So we've got our x1, we've got our y1, we've got our a, and our b, and our c. We're going to plug in our distance formula. So we've got a times x1 plus b times y1 minus c. Those bars on the top are just an absolute value sign. And then on the bottom, we've got the square root of 7 squared plus 1 squared. So we get 20 on the top and root 50 on the bottom, which works out to about 2.83 units. If you're interested in where that formula comes from, you can send me an email and I'll link you to where you can find the solution and go through it. It's fairly complicated to derive algebraically, but you do have the mathematical background to understand it if you'd like to explore that. Good luck with the homework questions. Hopefully you get some good practice in.